Hello everyone. Today I'm going to go over the concept of mole. This is a really important concept for physical chemistry, and it's a really interesting one too. So yeah, let's get started. So you just pay attention. This is going to be a really interesting topic. So first of all, concept of mole. What is a mole? So what is a mole? To understand mole, let's first discuss what is a dozen. You guys may know a dozen is 12 of anything, which means that if I say that I have a dozen bananas, it means I have 12 bananas. Similarly, if I say that I have a dozen pencils, it means that I have 12 pencils. The same thing is with mole. If dozen means 12 of something, then a mole means 6.023 into 10 to the power of 23 of something. I know that's a mouthful, but let's continue. So mole means 6.023 into 10 to the power of 23 of something. So if I say that I have a mole of bananas, it means that I have 6.023 into 10 to the power 23 bananas. If I have a mole of pencils, it means that I have 6.023 into 10 to the power of 23 pencils. So that's very basically what is a mole. But why is the number so specific? Like, why it's so specific? Why just 6.023 into 10 to the power 23 and nothing else? There's something very special about this number. And that special thing is that a mole. So one mole, which means 6.023 into 10 to the power 23, carbon 12 atoms. So atoms of the C12 isotope of carbon, 6.023 into 10 to the power of 23 carbon 12 atoms make exactly 12 grams of carbon. Yes. So why is it so special? This is so special because it is experimentally found out that 6.023 into 10 to the power 23 atoms of any element make the equivalent mass in grams as its molecular mass. What did I say? What does this mean? Let's understand this by an example. For example, oxygen. The molecular mass of oxygen. Oh, let's consider atomic mass for now. So atomic mass of oxygen is 16 atomic mass units. Right? It means that oxygen has exactly 16 protons in its nucleus. Sorry, 16 nucleons in its nucleus. So what are nucleons? Nucleons are just protons plus neutrons. So oxygen has exactly 16 protons and neutrons in its nucleus together. So if I take 6.023 into 10 to the power of 23 atoms of oxygen, it will make exactly 16 grams of oxygen. Isn't it fascinating? It also means, suppose that let's take sulfur. So the atomic mass of sulfur is 32 atomic mass units. So if I take exactly 6.023 into 10 to the power of 23 atoms of sulfur, then I get exactly 32 grams of sulfur. Tell me that's not fascinating. The same thing is with molecules. Let us consider carbon dioxide. So carbon dioxide. Because this is a molecule, so it won't have atomic mass. Rather, it will have molecular mass. So the molecular mass of carbon dioxide is 12 for carbon and 16 for each of oxygen. So 16 into, there are two oxygens, 16 into 2, which makes 12 plus 32, which is just 44. So the molecular mass of carbon dioxide is 44 atomic mass units. So if I take 6.023 into 10 to the power 23 molecules, not atoms, because it's a molecule, molecules of carbon dioxide, I will get exactly 44 grams of carbon dioxide. That's the magic of this number. And this particular number, 6.023 into 10 to the power of 23, is called Avogadro's number. This person was a scientist, and this number is named after him. So Avogadro's number. And it is also denoted by N and then a small capital A. Not Na, because that means sodium. N and capital A, like this. This makes Avogadro's number. 6.023 into 10 to the power of 23. A very special number indeed in all of chemistry. So how are we gonna do questions on this? Questions based on this are gonna come like this. For example, let's see. How many grams of oxygen do we get if we have 12.046 into 10 to the power of 23 atoms of oxygen? Questions like this. This is one of the most basic questions which can come. So how many grams of oxygen do we get if we have 12.046 into 10 to the power of 23 atoms of oxygen? So we know that atomic mass of oxygen is 16 atomic mass units. And 1 mole of oxygen is equal to 6.023 into 10 to the power of 23 atoms, right? And that is also equal to 16 grams of oxygen, because 6.023 into 10 to the power of 23 of any element makes the gram equivalent of its molecular mass. So if molecular mass of oxygen is 16 AMU, then Avogadro's number atoms of oxygen will make 16 grams of oxygen. So 6.023 into 10 to the power 23 atoms of oxygen makes 16 grams of oxygen. So how many grams of oxygen will 12.046 into 10 to the power of 23 atoms of oxygen make? Oh my god. So how many atoms will this make? Let's see. So we have an equation right here. 6.023 into 10 to the power of 23 will make 16 grams of oxygen. And then if we divide both sides by this number, Avogadro's number, we get 1 here. And this side, 16 divided by 6.023 into 10 to the power of 23 grams of oxygen. It means that 1 atom of oxygen weighs this much grams, and we need exactly this much number of atoms. So what we do, we multiply the equation on both sides by 12.046 into 10 to the power of 23. So 6.023 into 10 to the power of 23 into 12.046 into 10 to the power of 23. Cancel them out. This cancels out by 2, and we are left with 32 grams of oxygen. So yeah, that's the most basic definition of mole. I hope you enjoyed the video. Thank you.